In this example, we're trying to verify that sine squared of alpha plus sine of alpha minus 2 over 2 sine of alpha minus 2 is equal to the sine of alpha plus 2 over 2. So I'm going to choose the left-handed side of this equation to work with and see if I can simplify it. So in the numerator, I notice that I have 3 terms, and the first term is squared, the second term is to the first power, and the last term is just a constant or a number. This kind of hints towards factoring. So I'm going to see if I can factor that numerator. So I'm going to start with 2 sets of parentheses, and I'm going to look at the factors of that first term. Well, sine squared of alpha, I can factor into sine of alpha and sine of alpha. And then I look at that third term, and the factors of 2 are 2 and 1. And it looks like that I want to have a positive 1 in the middle term. So I'm going to make the 2 positive and the 1 a negative. And then that'll give me a positive sine of alpha if I was to FOIL that back out. I also noticed that in the denominator that there's 2 terms and there is a common factor of 2. So I'm actually going to factor out a 2 from the denominator as well. So I end up with 2 times the sine of alpha minus 1. So now at this stage, I notice that there is a sine of alpha minus 1 in the numerator and a sine of alpha minus 1 in the denominator. So I can cancel out or divide out both of those, and that leaves me with the sine of alpha plus 2 in the numerator and 2 in the denominator, and we see that we've verified that identity. So let's recap how we verified this identity. So the first thing we did was factor the trinomial in the numerator, and then we factored out the greatest common factor in the denominator. From there, we were able to simplify the sine of alpha minus 1 that was in the numerator and the denominator, and then that verified our identity. Notice we didn't actually use any of the identities that we have on our list of identities. We just did some good old-fashioned algebra.